Hello everyone, welcome to the Learn Medicine Easily YouTube channel. Today we will start our lessons with the ECG part 2. So what is and don't forget subscribe our channel and also push the bell button to receive the notification of our new videos. First watch our videos and also support us. So today in this lessons we will study about electrophysiology of the heart. As I told in the previous lessons that the recording of electrical activity of the heart is called electrocardiography or ECG. So today we will study about these electrical activity of the heart. So we if you want to study about these things, we should know the normal electrophysiology of the heart. I will briefly explain the events of which is occurring in the heart. So electrical events which are occurring in the heart. So let me explain these things. So the learning objective of this studying of electrophysiology of the heart, it means that if you study this electrophysiology of the heart, what you will learn and what you will study in the electrophysiology of the heart. So first and very big thing is factors which produce ECG, and also normal heart cell electrical activity, and also what is cell potential, what is intracellular potential, what is rest potential, what is action potential, and also what is threshold potential, and what is refractory period. It means if we are studying electrophysiology of the heart, electrophysiology of heart. So what are the basic concept in the electrophysiology of the heart? These are the basic concept in the electrophysiology of the heart. These are the basic concept. So when you are studying electrophysiology of the heart, you should know these things, that factors which are responsible to produce ECG, and also you should know normal heart cell electrical activity, what events or what activity or which activities are occurring in a heart cells, and also what is cell potential, and also what is intracellular potential. So you should know these things, what is rest potential, and also what is action potential, and also what is threshold potential, and what is refractory period. So in the electrophysiology of the heart, you will learn these things. So let's come to the next slide. So the first thing, factors which produce ECG, we will talk about these factor which has role in ECG producing. So mainly we have four factors. So these four factors are responsible to produce ECG. These four factors are responsible to produce ECG. So what are these factors? So factor 1 is starting electrical impulse in pacemaker. Electrical impulse, starting electrical impulse in the heart pacemaker. If this is the pacemaker, so an electrical impulse is, this is, suppose this is pacemaker, electrical impulses will produce in this pacemaker, and this is the first factor in the producing of ECG. And also you should not forget these three other factors. So then this electrical impulses should conduct or move through some things. So it is moving through the cardiac conductive system. So this is the second factor. Factor 2, conduction of this electrical impulses through the cardiac conductive system. CCS is for cardiac conductive system. So this electrical impulses should move. If it is remain and it is first point, so it will not produce ECG. But if it move through the cardiac conductive system to the other cardiac cells, so it will produce ECG. In the third factor, or factor 3, so when this electrical impulse is coming to the myocardial cells, so this electrical impulse is coming through this cardiac conductive system to the myocardial cells. So suppose this is a myocardial cell, so this impulse will depolarize this cells and give it shape like this. Outside will be negative and the other side, enter the cell, will be positive in the response to this impulses. So an impulse will produce in the pacemaker. It is coming through the cardiac conductive system to the myocardial cells, which cause the depolarization of myocardium. And this depolarization will again repolarized, or repolarization should occur. So this depolarization factor 3 and this repolarization factor 4. So this depolarization will go back to the normal condition, which process that change the depolarized cell to the normal condition. It is called repolarization. It means this cell will repolarized again, so it will come like this. So normally the negative charges are in the cell and the positive charges are in the outside of the cells. So the first, as a conclusion, so the first factor is starting electrical impulses in this SA node, and then the second factor is conduction of this electrical impulses through the cardiac conductive system. So when this electrical impulse is coming to the myocardial cell, they change their shape from this shape, a normal shape, to the depolarized shape. So they are depolarizing myocardium. So the third factor, or factor 3, is depolarization of myocardium, and then the fourth factor, or factor 4, is the again this cell will come to the normal condition, which process is changing this condition to this condition, is called repolarization. So this is the repolarization is the fourth factor, or factor 4. So as I mentioned here, that starting electrical impulse in pacemaker is the first factor in ECG producing. So you should know that what is this pacemaker. What is this pacemaker? I'm telling about this pacemaker in this slide. So what is normal heart pacemaker, or simply pacemaker? Simply what? Pacemaker. This. So it is located in the superior lateral wall of the right atrium. So this is left atrium, this is right atrium. It is located in the superior lateral wall of the right atrium. And also the other name for this is sinoatrial node, or simply SA node. Simply is a node. The other name for this normal heart pacemaker is SA node. And then when special type of ion entering to the cells of the sinoatrial node, so it is start producing electrical activity. So I will explain these things later in the next slide. And also as they connected to the other heart cells, there all the cells of the sinoatrial node are connected to the other cardiac cells through the gap junction. So the electrical impulses can easily go from SA node cells to the other cardiac So as a conclusion, you can easily remember its location, which is located in the superior lateral wall of the right atrium, and also the name of other name of for this node, sinoatrial node, and also when some special type of ion entering to the SA node, it have channels in its wall. So this is suppose it is a single cell of SA node. So if this is a single cell of SA node, so this cell have special channel in its wall, so it allows sodium ion, sodium positive ion or positive ion to enter to the cells. So when this sodium positive ion, when these sodium positive ions are entering to the SA node, so it produce some electrical activity. So electrical activity which are producing in the response to this sodium entry will conduct to the other cardiac cells. So the first factor is producing electrical impulses in the SA node. So electrical impulse or producing in the SA node when sodium ion enter to the cell. These sodium ions are depolarizing the SA node cells. So this depolarization is responsible for producing electrical impulses, which can easily go to the other cardiac cell through the gap junction. So gap junction means in this type of junction there are special gap from which ions or impulses, electrical impulses can easily go from one cell to another cell. As you know, the cardiac cells have a special type of disc which is called intercalated disc. Horizontally or they are located through the intercalated disc, and this intercalated disc has gap junction between two cells. So when a electrical impulse is coming to the first cell, suppose this electrical impulse is coming to this first cells, so it will easily go through this gap junction to the other cells, and then it is going to the other cells, and again it is going to other cells, and all of the myocardium will reach this electrical impulses. So you can, as a conclusion, easily say that SA node is located in the superior lateral wall of the right atrium. It has a special ability to produce electrical impulses, which electrical impulses can go through the gap junction to the other cardiac cells, and then from one cardiac cell to other cardiac cells, and all the myocardium will depolarized in the response to this impulses which is produced by SA node. So this SA node activity is controlled by sympathetic and parasympathetic nerve, sympathetic and parasympathetic nerve, sympathetic nerve or parasympathetic nerve, parasympathetic nerve. So it is controlled by sympathetic nerve and parasympathetic nerve. When sympathetic nerve is give order to the SA node, it increase the heart rate or the producing impulses, and when parasympathetic nerve giving order to the SA node, it decreased the activity of SA node or producing electrical impulses in the SA node. So a balance between sympathetic nerve and parasympathetic nerve make the producing of electrical impulses of SA node between 60 to 100, or easily we can say 100. So this 100 is the heart rate also, because every single impulse in the SA node can produce a myocardial contraction or a beat. So we can conclude the heart rate like this. This is 100. So this 100 is produced by a balance between sympathetic nerve and parasympathetic nerve. If these two nerves are not present, so SA node produce impulses more than 100. So you can easily see the importance of sympathetic nerve and parasympathetic nerve in the SA node function. Then these impulses which are produced in the SA node first go to the atrium, left atrium and right atrium, and then they are coming to the other node which is located in the junction point of ventricle and atrium, which is called AV node, atrioventricular node, and then these electrical impulses through the cardiac conductive system go to the ventricle. So I will explain the cardiac conductive system also. So as you know that heart has 4 chamber, left atrium, right atrium, and also right ventricle and left ventricle. So this cardiac conductive system is made from SA node, AV node. So you can easily see the part of this cardiac conductive system. Number 1 is the SA node or sinoatrial node. Number 2 is the atrioventricular node. Number 3 is the atrioventricular bundle. I will show these things in this picture. You can easily learn these things. And also the bundle branches and the Purkinje fiber. So the first thing is SA node. I talked about SA node in the previous slide. It is located in the superior lateral wall of the right atrium, and then the other, so these are the component of the cardiac conductive system. So the first component is SA node, and the second is the AV node, which is located in the junction point of atrium and ventricles. So then from AV node to the division point, it is called atrioventricular bundle or his bundle. Atrioventricular bundle or his bundle. Or what? His bundle. Atrioventricular bundle or his bundle. And then it is divided into 2 branches. So right bundle branch and left bundle branch, which are conducting electrical impulses. Right bundle branch to the right heart, right ventricle, and left bundle branch to the left ventricle. And then in the last and very little points are in the wall of the myocardium, we have special type of fibers of this conductive system which are called Purkinje fiber. So these Purkinje fiber are responsible to give the electrical impulses to the myocardial cells, and then it is going from one cell to other cells through the gap junction, and all the myocardium is contracting. So thanks for watching. Subscribe our YouTube channel, also share our channel with your friends, watch our videos, support us. Thanks again for watching. Our today's lesson was finished in this point, and in the next lecture we will talk about the remaining electrophysiology of the heart.